Welcome back, students. So, our next topic is power of lens. So, what's the power of concave and convex lens? What is meant by power of a lens? Power of lens is defined as the reciprocal of the focal length in meters. Reciprocal of its focal length in meters. That is known as the power of lens. Then one more definition is there, that is a degree of convergence or divergence of the light rays achieved by a lens. That is a degree of divergence or convergence achieved by a lens when light rays passes through it. That is known as the power of a lens. That is given in your textbook, page number 183. The heading is power of the lens. So, we know convex lens will converge the light rays to a point and concave lens will diverge the light rays to a point. Concave lens will diverge the light rays, and we have a feeling that the light rays are coming from a single point. So, we know the lens will diverge or converge the light ray. So, what is the degree of divergence or convergence of the light ray achieved by a lens? That is known as power of the lens. One more definition is there, that is a reciprocal of its focal length in meters. Reciprocal of its focal length in meters. Now, the SI unit of power is diopter. It is denoted by the letter capital D. The SI unit of power is diopter. It is denoted by the letter capital D. 1 diopter means that is the power of the lens if the focal length of the lens is 1 meter. If the focal length of the lens is 1 meter, then its power is 1 diopter. Then just underline it in your textbook, page number 183. The ability of a lens to converge or diverge the light ray depends on its focal length. A convex lens of short focal length bends light rays through larger angles by focusing them closer to the optical center. A concave lens of very short focal length causes higher divergence than one with longer focal length. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. The power of a lens is defined as the reciprocal of its focal length. It is represented by the letter P. Then the power of the lens is given as P equal to 1 by F. There you write one more equation, that is P equal to 100 by F if it is given in centimeter. If the focal length is given in centimeters, then we can use this equation. This one will be easy for you to calculate. Okay. Otherwise, you will forget to convert it into centimeters. Okay. Or to meter. Then, so one more equation we can write, power equal to 100 by F in centimeter. That equation you just write in that page. 183 equation 10.11. Then SI unit of power is diopter. It is denoted by the letter F. Then 1 diopter is the power of the lens whose focal length is 1 meter. Then the power of convex lens is positive and that of concave lens is negative. That I will show you. I am drawing it here. this is the principal focus and this distance is the focal length. For convex, we will measure it from the optic center towards the right. From the optic center towards the right we will measure. So, that distance is positive. Focal length is positive. So, power is also positive. Okay, here focal length is positive. So, power is also positive for convex lens. Now, for concave lens, the focal length is negative. Focal length is negative, like this. This is the principal focus. So, this distance is focal length. We will measure it opposite to the direction of incident light ray. So, focal length of concave lens is negative. So, its power is also negative. Opticians prescribe corrective lenses indicating their power. Let us say a lens prescribed with a focal length plus 2 diopter. Positive value is there, then that is a convex lens. So, positive value in the power indicates that the lens is a convex lens. Then negative value is there, suppose 1.5 minus 1.5 diopter. Negative value is there in the diopter, that represents the concave lens, because power is negative for concave lens. Okay. So, if power is given as positive, then it is convex lens. If it is given as negative, then it is concave lens. Just that also you underline it in your textbook. Power equal to plus 2d diopter. This means that the prescribed lens is convex. The focal length of the lens is 0.5 meter or 50 centimeter. That we will do it. Similarly, lens of minus 2.5 diopter is concave lens. Now, many optical instrument uses a number of lenses. So, in order to find the combination, the power is given, combination of lenses are there, then the power is given as P equal to P1 plus P2 plus P3 plus etc. So, if two lenses are there, P1 plus P2. Just underline that point also. The net power of the lenses placed in contact is given by the algebraic sum of the individual powers P1, P2, P3 as P equal to P1 plus P2 plus P3. Now, then for example, a combination of two lenses of power plus 2 diopter and plus 0.25 diopter is equivalent to a single lens of 2.25 diopter. If both values are positive and negative, we will add it together. If one value is positive and one value is negative, then according to the, we will do the answer. Then combination, the same thing, combination of the lens, that is P equal to P1 plus P2 plus P equal to P1 plus P2. Here we can write, instead of this equation, P equal to P1 plus P2. What is P? P1 is 1 by F1 and P2 1 by F2. P means the power of the combination. If two lenses are used as a single system of lens, then we can find the power using the equation P equal to P1 plus P2, combination of lenses. Then lesser focal length If focal length is less, then the power will be more. Focal length is less, then the power will be more. Here, in this case, the focal length is less. The focal length is less means the power of this lens will be more, or this lens will converge the light ray very close to the lens, or the lens will converge the light ray very close to the lens. Here this focal length is more, focal length is more, so power will be less, power will be very less. That is the difference between thick lens and thin lens. Thin lens is having more focal length, thick lens is having less focal length. You can see the curvature. This one is thick lens, this one is thin lens. So, thick lens the focal length is less means the power will be more. For thin lens the power is less because it is having more focal length. Here the focal length is more, this much distance is more, so the power will be less. That point, just write it in your page number 177. Set above that activity 10.11, the lenses whose aperture is less than its radius of curvature, such lenses are called thin lenses. There you write thin lenses, focal length will be more, power will be less. You just write that point there. Thin lens, focal length more, power will be less. Power will be less. Page number 177. Now, we need to find the power of a concave lens of focal length 2 meter. We need to find the power of a concave lens whose focal length is 2 meter. That is a question. Find the power of concave lens whose focal length is 2 meter. Focal length is 2 meter. So, concave lens, focal length 2 meter means the value will be minus 2. So, we will write F equal to minus 2 meter. F equal to minus 2 meter. Now, what is the equation to find power? P equal to 1 by F. P equal to 1 by F. So, what is the answer? That is equal to 1 by 2 minus 1 by 2 meter. Minus 1 by 2 meter, that is 0.5 diopter. Minus 0.5 diopter. Okay, minus 0.5 diopter. That is the answer. Okay. Then next question is, a convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. That is question number 2, blue question, question number 2. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. Where is the needle placed in front of the convex lens? If the image is equal to the size of the object, also find the power of the lens. Also find the power of the lens. Okay. So, image distance is given. This question I will not write the question, I will just solve it. Question number 2, page number, that is 184, blue question. Okay, 184 blue question. The question is, a convex lens forms a real inverted image of a needle at a distance of 50 centimeter from it. So, image distance is given 50 centimeter. Now, where the needle placed in front of the lens if the image is equal to the size of the object. Now, in which case you will get the size of the image and size of the object same, that is when the object is placed at 2f1, you will get the image at 2f2, size of the object and the size of the image will be same. So, image is at 50 like this, it is 2f1, this distance is u, here 2f2, this distance is v. So, this distance is given as 50 centimeter. So, what about this distance? That distance also 50 centimeter. So, u equal to minus 50 centimeter, because we are measuring opposite to the direction of incident light ray. Now, what is the question? Find its power of the lens. You can find a power. If you want to use a lens equation, 1 by f equal to 1 by v minus 1 by u, you can find the focal length. Or using your logic, this distance is 2f1, this distance is 2f1 and this distance is 2f2, both are same. So, what is f1 and f2? That is 2f equal to 50 centimeter, 2f equal to 50 centimeter. So, what will be f? What will be f? F equal to 50 by 2, that is equal to 25 centimeter. 25 centimeter. Now, how will you find the power? If focal length is given, P equal to 1 by f. P equal to 1 by f. That is, or you can use the equation 100 by f in centimeters, that is 100 by 25, 100 by 25, that is plus 4d, plus 4d. That is the answer for this question, plus 4d. Okay. So, power is the reciprocal of its focal length or the degree of convergence of divergence achieved by the light ray when it passes through a lens. That is known as the power of the lens. So, shorter focal lengths having more power, shorter focal length lenses having more power, longer focal length lenses having less power. Thin lens will have more focal length and less power. Thick lens will have less focal length and more power. The equation is P equal to 1 by f. Diopter is a SI unit of power. 1 diopter means when the focal length of a lens is 1 meter, then the power is known as 1 diopter. If the focal length is positive, then power is also positive. That is for convex lens. If the focal length is negative, the power is also negative, that is for concave lens. If two or more lenses are there in a system, then we will find the total power using the equation P equal to P1 plus P2 or 1 by F equal to 1 by F1 plus 1 by F2. F1 and F2 are the focal length of that lenses. If they are having same sign, then we will add it together. If they have different sign, then we will subtract it together to find the effective power or net power. Okay, thank you.